Let's do more examples using this tool, ARIO. Okay, now I'm going to give you a series of structures, and we're going to determine which of the acids that I'm presenting to you is stronger. We're going to rank them. So first, I'm going to draw this. A molecule is an alcohol. Then I'm going to draw another structure here that is phenol. And I'm going to give it a letter B. Then I'm going to give you another structure, and that is a carboxylic acid. All right, so in fact, this is ethanol, phenol, acetic acid. So, and let's rank them and see, we need to give an order of acidity, so decide which one is stronger. And for that, what we're going to do, we're going to form the conjugate bases of all of these, and we're going to use ARIO to analyze the stability of the conjugate bases. So by removing the hydrogen here, and I always want to put my lone pairs in my Lewis structures. We don't want to forget lone pairs. Okay, now let's remove the hydrogen here at the oxygen. And we're going to form the conjugate base here. So that's my conjugate base, and of course it's going to have a negative charge. Conjugate base of phenol here. And I'm going to draw the O on the side, but it's the same thing, just to have more room. This is identical, just conjugate base. Now I am removing this hydrogen, and I am forming the conjugate base. I'm going to have an extra pair of electrons, right? That's why I wanted to draw that. All of my conjugate bases. Next step after I do that is analyze using this tool. I don't have a pK chart. So here, the first thing I am observing is that atom is the same charge, negative charge on oxygen, oxygen, oxygen. So I'm going to move on to the next factor, which is resonance. And what I see here is that this carbon is sp3. So electrons here are localized, and I cannot draw any resonance structure, so no resonance. Electrons here are localized, being this sp. Remember, we cannot expand the octet. Now, this one here, let's pick one of the lone pairs. We have one lone pair that can be delocalized because it is allylic, so next to a double bond. The other two will be localized, but this actually is delocalized. One of them, I just picked one of them randomly. Delocalized, and that means I can do resonance. I can do this. And that will lead to a resonance structure with a negative charge here, and I have more. So I have resonance effects here. And all of the resonance structures in this molecule are going to place negative charges in this carbon, in this carbon, and in this carbon. So draw them all, move your electrons around so that you know all the resonance structure. But negative charge is going to be here, here, and here in the different resonance structure, but on a carbon. Now, but if I do my resonance here, again, here we have one lone pair that is allylic, so next to a double bond, and the other two will not be will be localized. Two localized, but this one being delocalized, I can do resonance. That means I can move those electrons like that. And this time I'm going to draw the resonance structure here. We didn't have much room, right? So resonance structure here is opening that charge on an oxygen. So notice the difference. There is resonance here, there's resonance here. But here, the resonance, when I draw it, charge is an oxygen, charge is an oxygen. That contributes much more than this structure that are placing charges, negative charge on carbon. So bottom line, these two have resonance. So they already are more acidic than that one, no resonance. So this is the least acidic at the end. So A is going to be the least acidic, and in between these two, here, these two resonance structure contribute equally to the resonance hybrid, and charges are an oxygen, so more stable than an ion. So The carboxylic acid is a stronger acid, so ranking them as say C is a stronger acid than B, and B is a stronger acid than A. Again, because this two, here we had resonance effects, but more important resonance structures in C. And here I didn't have any resonance effects. So right there, that's how I rank my molecules to see which one is more acidic.